Hello everyone, my name is Siti Khadija and today I will be presenting my sentiment analysis project. This project is divided into two main parts, text processing and model implementation. The goal of this project is to analyze sentiment expressed in text data, which can be valuable for various applications such as customer feedback analysis and social media monitoring. So now we go to the introduction part. In this project, we explore a sentiment analysis using deep learning techniques. Our goal is classify a sentiment into positive, neutral, and negative categories. They have three categories, and by utilizing the recurrent neural network, we aim to effectively capture the sequential nature of the text, enable accurate sequential nature of the text data, enable accurate interpretation of customer opinion and public sentiment. And objective of this project is to classify a sentiment as a positive, neutral, or negative, like I mentioned before. And the method that we are using is by utilize deep learning technique and which is specify recurrent neural network. And what is the significance of the project is to analyze and interpret the sentiment in text data effectively. So next we go to the key component. So for the first component is pre-processing, which is we clean and prepare text data for analysis. And this is a very crucial thing that we need to do before we do the other step. And for the second step is the model architecture, which is we use the embedding layer method, LSTM, GRU layer, dropout layers, and then output layer. So let's start with the part one, step one of the text pre-processing decision, which focuses on text pre-processing. This is a crucial step in preparing raw text data for analysis. I implemented several processing steps in order to clean and standardize the text. And first, I expanded the construction using a mapping dictionary. For example, don't was converted to do not, and this is helped to maintaining a consistency in the text. And next, I removed the email address using a regular expression to identify and eliminate any email patterns, and this is ensure that irrelevant information does not interfere with the sentiment analysis. And I also remove HTML tags which can appear in text grab from the web. For instance, that like P and A were stripped from the text, and URLs were removed in the similar fashion using a regular expression to identify the eliminate any web link. Um, Also, the special character and the number were also removed, keeping only the alphabetic character and spaces. This is helped to in focusing solely to the words that convey sentiment. And to handle the accents character, I replaced them with a non-accented equivalent, such as converting E to E, and on top of it, like have a symbol to the E. And finally, I normalize the text by converting it to the lowercase and removing extra white space. And I also implemented the basic spelling correction to enhance the quality of the text data. So now let's move on to the part two, which involve model implementation. I integrated the glove embedding, which are pre-trained word factor that capture semantic relationship between the words. I downloaded the 100-dimensional glove vector and created an embedding metric for my vocabulary. This metric map each word is corresponding glove vector, and I handle words not found in a glove by assigning them a random vector. And as you can see in this slide, this is how I download the glove embedding. And this could check if the glove embedding file exists. If it not, it's download and the zip file Stanford NLP website and extract it. And this is how I do it. Um, for the glove embedding integration, I do like at first have a three step. First, I downloading And second is will be load, and third we create the glove embedding. So actually there's a lot of step, but I didn't include in this video because there's a lot. But you can check for the code that I have met. This is a lot, like there is a lot of step. So the next is the neural network architecture. I design and includes an input layer that accepts tokenized and padded sequence. The embedding layer use the pre-trained glove embedding to enhance the model understanding of the language, and I include an LSTM layer to capture temporal dependencies in the text data, followed by dense layer to learn complex representation. So the output layer uses softmax activation function to classify a sentiment into three categories, which is a negative, neutral, and positive. So the next one, the last one is for training. I implemented early stopping to prevent overfitting and train the model for at least five approach. And after training, I evaluated the model on the test and for the test on the test set and reported metrics such as accuracy, precision, recall, and F1 score. So this is the last result that I get from my coding. So as you can see, like we separate with the three categories, like I mentioned just now, and this is as the result of it. So, in conclusion, pre-processing steps were essential in cleaning the data and preparing it for analysis. So, the model architecture effectively utilized LSTM layer and pre-trained embeddings, but the result highlighted the need for the future tuning and possibly more complex architecture to improve in performance.